What's up, everyone? Welcome back. Patrick here. Moving on to the next question. We have to solve for x in this equation. X minus 4 times the absolute value of 3x minus 1 equals x times the absolute value of 3x plus 4. So like we did in the previous examples where we had multiple absolute values within an equation, what you want to do is you want to take the absolute values, change them to piecewise function, and find those breakpoints. So if we follow that same process, so this absolute value of 3x minus 1, that's going to equal 3x minus 1 when x is what? Greater than or equal to 1 over 3. Right? If we follow that exact same process, hopefully by this point you're pretty comfortable in taking these absolute values, changing them to piecewise functions. If you're not yet, then go back to the previous videos. I'd recommend doing that first and get comfortable with going from here to here. So it stays as is. If x is greater than or equal to 1 over 3, this will be positive and then 0. Now, if it's negative, then we got to change it by multiplying it by a negative 1 to change it to a positive. And this is going to be negative when x is less than 1 over 3. And then if we follow that same process for this absolute value of 3x plus 4, this is going to equal 3x plus 4 when x is greater than or equal to negative 4 over 3. It's going to equal negative 3x plus 4 when x is less than negative 4 over 3. Right? When x is less than negative 4 over 3, this expression within the absolute value is going to be negative. So we've got to multiply it by negative 1 to change it to a positive. So notice that the two breakpoints we're working with, negative 4 over 3 and then 1 over 3. So if we create a sign chart here, just to kind of visually show this, like I did in the previous examples. And then really what we're concerned about is the absolute value. So the absolute value of 3x minus 1, and then the absolute value of 3x plus 4. So notice that it's going to be negative when x is less than 1 over 3. So in this interval, and that interval, and then here it's going to be positive. And then this is going to be negative when x is less than negative 4 over 3. So in this interval, right, x is less than negative 4 over 3. Then when it's greater than negative 4 over 3, it's going to be positive, and then positive, like that. So now what we want to do is we want to look at these intervals separately. So the first one we would look at is when x is less than negative 4 over 3. And notice that both of these are going to be negative. So what would happen is we'd have x minus 4 times negative, times basically this factor. The negative I'm actually going to put in front. Then we'll have 3x minus 1. Right? I took this, brought it in here, but then I split it up. The negative one I put in front. And then we have x times absolute value of 3x plus 4. Within this interval, that's going to be negative as well. So I'm going to put the negative in front here too. Now notice that both of these have a negative in front. So we could actually just divide both sides by negative 1. And then the negative would go away. You could keep it. You could distribute it within if you want. You'd get the exact same answer. But I'm just going to divide both sides by negative 1, so that negative in front is actually irrelevant because it's on both sides, like that. And now we have this equation, we can just expand and solve. So we'll have 3x squared minus x minus 12x plus 4, right? And then we'll have 3x squared plus 4x, like that. So what I'm going to do is notice that the 3x squares are actually going to net out to 0, right? Because when we bring this over, those are the only two like terms. 3x squared minus 3x squared would be 0. So these actually net out. And then I'm going to bring all of the x's to the right side. So we'll have 4 equals 4x plus 12x, like that when we bring these two to the right side. So here we'll have 17x. So x would be 4 over 17, like that. 4 over 17, notice that that is not within this interval. It's not a value that's less than negative 4 over 3. And so this is an inadmissible answer, right? So it's the answer to this equation, but it's not going to be an answer to this equation. It may be on other intervals when we test, but for this interval, it's not, right? Because this is not less than negative 4 over 3, so we ignore that solution right there. Now, what about the next interval? So that's going to happen when x is greater than or equal to negative 4 over 3, but less than 1 over 3, right? This interval right here. So notice what's going to happen. The absolute value 3x minus 1, that's going to stay negative. So same thing, I'm going to put it on this side. And then we'll have x times the absolute value of 3x plus 4 is going to be positive. Like that. So now this negative is important. We can't just cancel it out because there's no negative on that right side anymore. So what I'm going to do in this case is still expand this like we did before. 3x squared minus 12x minus x plus 4. And this would be 3x squared plus 4x. And then I'm going to distribute the negative inside the bracket. Change all the signs. And then let's bring everything to the right side, just because then the leading coefficient is going to be positive. This negative 3x squared plus 3x squared, that's going to turn into a plus. Then we're going to add those, we're going to get 6x squared. So we would end up with 0 equals 6x squared. This would be 13x. When we bring it over, 4x minus 13x would give us minus 9x. And then that would be plus 4, like that. Okay, let me just make sure that we're all good here. Yeah, so this here would end up being the quadratic equation that we have to solve. And this quadratic equation, if I rewrite it up here, this is actually going to have no solution. Because what's going to happen is this doesn't factor smoothly, and if we input it into the quadratic formula, the discriminant is going to be negative. So basically we'll have negative b, so we'll have 9 plus or minus negative 9 squared minus 4 times the a value times the c value, all over 2 times the a value. And we didn't even have to write all this out. We could have just wrote out the discriminant, which is the expression that's under the square root. Remember, if the discriminant for a quadratic is positive, then there's 2 answers, 2 solutions, 2x intercepts to that quadratic, right? Because then this is going to be plus or minus square root of a positive number. If it's 0, there's going to be 1. But if it's negative, then there's going to be none. And notice it would be negative because we would have 81 minus 24 times 4 would be what? 96. So this here would end up being negative 15. Right? So we can't square root a negative number. And so this just has no solutions, this quadratic here. Right? So in this interval, there's just no solutions to worry about. And then finally, the last interval, when x is greater than or equal to 1 over 3. This interval here, notice both of these would be, the absolute values would be positive. So we would end up with x minus 4 times 3x minus 1 equals x times 3x plus 4. And this is actually, remember in this first interval we worked with, when we canceled out the negatives, we ended up with this expression. This is the exact same expression we had, and the solution of that was 4 over 17. And notice that 4 over 17 is less than 1 over 3. So same solution, but it's also not admissible on this interval, right? Because 4 over 17, if we compare it to 4 over 16, notice 4 over 16 is what? 0.25 or 1 over 4. And notice 1 over 4 is less than 1 over 3. Right? 1 over 3 is like 0.333, and then 1 over 4, 4 over 16 is 0.25. Now notice that 4 over 17, if we add 1 to the denominator here, it's going to be less than 0.25. And this is already less than this. Right? So just by deductive logic, 4 over 17, it's tough to see what that fraction is going to be, but if we do 4 over 16, 1 over 4, or 0.25, it's already less than this, so if we add 1, this is going to be less than this, which is less than that. Right? So 4 over 17 does not work on this interval. And that's all the intervals. And so notice we got no solutions for all three, which means that this equation here has no solutions. Right? So that ends up being the final answer for this over here. So even though we got 4 over 17 here, we got 4 over 17 here, it's actually not a solution. If you were to plug it in, you would notice that left side does not equal the right side with 4 over 17. So this overall equation here has no solutions.